Hello, everyone. Again, thanks for joining and welcome to another session of our Day 1 and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Today's session is OCI Database Quickstart, where you'll learn about the database services and tools available in Oracle Cloud. Before diving into that, I have a quick poll on the screen. Nick, if we can have the poll, please. Okay, I guess some technical difficulty there. If the poll comes in, it's just to get an understanding of everyone's level of experience with cloud. But we can always do that later. This session is being recorded and you'll be able to find the recording on Cloud Customer Connect. You can also find the recordings and slide deck PDFs of our previous sessions there. I'm Renu Bhatt, a TPM with the Customer Enablement team. And today I'm joined by Sunil Jain, Cloud Engineer, and Lynn Lewis, Senior Cloud Engineer, as the main presenters. And we have Anand Prasad joining us as an expert on database today. Like always, a quick reminder to use the Q&A box down at the bottom of the screen for any questions throughout the session. And with that, I'll hand it over to Len. Please take over.
Thank you. Next slide.
Yep.
All right, so this is what we're going to cover today. We're going to go over the database services. We're going to do it in order of starting with the most management to the least management, and then come back to Exadata Cloud Service and Cloud at Customer. We're going to talk briefly about DataGuard and then Oracle Golden Gate and MySQL, and then we'll be doing a short review of the service menu for Autonomous. We have to move quickly here, so let's go on. So this is about using a converged data platform on top of Oracle's cloud. And so the key elements to this are background and security, our observability and management and compliance and governance puts all this as a base. Then we put the infrastructure on top of that, including, I would point out, software-defined networking, which allows the industry to really do this. And then today we're going to be talking about the converged data system. It's converged in the sense that it's not your grandfather's relational database anymore. It adds a lot of additional data references to it. So next slide. So this is going to be the primary aspect of our discussion. You note that at the far left-hand side, you have Oracle Database on Compute. This is I would say the most straightforward. You simply bring your own license, or you can arrange through a license for the work that you want on a virtual machine or a bare metal machine and then configure it, put it together exactly like it was on site. You're responsible for all of it, every aspect of it, from beginning to end, from loading it up, from migrating your database to that database, everything. The next two are cloud services. Number one, Oracle Database Cloud Service, and then Oracle Exadata Cloud Service. The essential differences between the two are where they can be implemented and also the kind of hardware that they're on. So number one, with Oracle Database Cloud Service, you're simply again having Oracle do some of the background work for you. We'll set up the automated patching and backup. You will tell us when it's okay to do it. We're going to include some DataGuard. We're going to include the capability of RAC. So all of this is bits and pieces that you can put together. The key element is you don't have to manage it. We provide you with additional tools for migration. We provide you with additional methodologies for that as well for high availability. With Oracle Exadata, all that is now on a Oracle machine that's designed for Oracle database. So the Exadata platform is a database appliance that is designed to take advantage of the software, or perhaps I should say the software is written to take advantage of the hardware underneath. The fully managed is the autonomous database, either warehouse or transaction processing. It's auto scaling, auto tuned, auto patching. It can be a function or it can be dedicated. It can be used in a variety of different manners, including spatial, machine learning, JSON documents, SQL developer can be utilized, as well as Apex. Next slide. So this is the database cloud service. It's very basic. It's fully featured. It's Enterprise Edition or Standard Edition 2. Both cases, you notice that include encryption. Nothing gets in the cloud, Oracle's cloud, without encryption in rest and in motion. So the database in particular, we're not going to let you go in there without it. And that's going to be up right now. We're accepting everything from 11.2 to 21C. We would really rather you not go with 11. I think we'd really rather you be at 12C and above. In particular, 19C, likewise, is probably where we'd like you to be. And then we'd like you to take a look at 21C, play with it, maybe build on top of it. But the next real long-term release is going to be 23, which you can download as a developer edition right now. Then those can be put on a virtual machine or in bare metal shapes. And the other key element, if you haven't been working with us before with Oracle's cloud, and frankly for most clouds as well, the UI is one way to do the thing, but it's all software now, and we've already built out the hardware for you. We've already put the systems up there, and we've already implemented the virtualization. We've already configured the different platforms. All the services are there. It's already for you to utilize. All you have to use is something like Terraform or Ansible or any OCI CLI, any other CLI that's been supported in the past with databases, all works. And you can write code that either be Python or Ruby or even Go that uses the SDKs for us as well. So it can be worked with the virtual machines, with rack or bare metal system, and for the two services and autonomous as well. If you're familiar with it, we also include at no cost the Enterprise Manager tuning and diagnostic packs. So that gives you a lot of capability that are now fully integrated in with our observability and manageability. Next slide. So this sort of sums up what we've gone so far. So it's a single database for all the data. It's simplified administration. We really have done significant amount of work to ease your administration, and it can be at whatever level of administration you want. You get to choose how much work you do on the administration side, how much you trust us versus how much you trust your folks, and not trust so much as how much you're willing to do versus let us willing to do, right? And it's multiple levels of enterprise database security, including data safe is also included in these systems at no extra fee. A lot of things as we're moving into OCI, into the cloud, we're just including it because it's better for us if you don't have any problems at any aspect. And that includes integrations as well. And Sunil's going to talk to that in a great deal more. So we call this a converged architecture because it includes, yes, your relational database, yes, your transaction processing, yes, your data warehousing and data lakes, and it also includes your document forms and in-memory SQL performance and in-memory machine learning and data science performance as well. So it's really how you want to deploy it and how much services you want to do yourself or let us do. Next slide. And next slide. And we realize that when I say, well, how much you do, it's how much your industry allows for you to do and where it's going to be done, right? And your security department, that also comes into play as well. So the autonomous data system, we're going to talk about that first. Note first, it's a query across multiple type silos. So you can use SQL, you can use JSON, you can use Java database code, you can use spatial tools, you can use value calls, it's key value calls. It's all based on what how you want to use it. It's all there. You don't have to move it around. It's all in your database. You just have to use the appropriate API and do what needs to be done the way that you want to do it. You can even use the same database with different microservices, each microservices addressing that same database with a different call. So that is the capability that this system happens at this time. And you'll note, we'll talk about this later, you'll note that in the upper left-hand corner, the line that goes across, that's for transaction processing. All your indices are in memory. Your on the top right-hand side, you'll see the compressed columnar. That's for your warehouses and those types of things. So that, again, you get the maximum speed, and all of that is in memory. Next slide. So this sort of sums it up. The Oracle Autonomous Database can be configured on initial install and as either a data warehouse, or a transaction processing, JSON, or to be utilized as an Apex app development service. Of note here is this is done through the UI or any of the other ways as mentioned. This is just about the initial configuration. This is so that our system knows where to put, how to put the data in memory. It's all going to go in memory, especially with autonomous. It's all in memory all the time. And this key element of this is just at the beginning to take advantage of either columnar compression or indices in main memory. Next slide. So the key element is that you can use a shared infrastructure or dedicated infrastructure with autonomous. Now, let's be clear. Both of these are on Exadata systems. So these are the most performant x86 hardware out there for Oracle's data systems. And whether they be shared or dedicated. In the case of shared, of course, means we've shared it out. There's multiple users, multiple databases, and we upgrade it when we need to upgrade it from a security perspective. We're not going to talk to you about it. You're going to come in one morning and it's going to be another level of patching. But at the same time, we're going to use the best methodology. We're going to be moving it through homes. We're going to do rolling. You're not going to see it. It's not going to affect anything you've done in a shared environment. The biggest difference between, instead of being software separated, you're going to be both software and hardware separated if you're in a dedicated infrastructure. That's where you've rented a minimum amount of an Exadata machine and you're not sharing it with anybody. And as a result, you have a little more control, operational control, on when we do patching. Next slide. Next slide. So you can do this with the Exadata box itself, and we can deploy it either in our cloud, in our service OCI, where we manage everything, or cloud at customer. We will put it in your data center, right? So it's just, but we will put a backplane on it so that essentially it becomes a fully complete part of Oracle's cloud. So you will have all the cloud services, everything that you can do in OCI on a public cloud, all that platform services, every aspect of control and our management of it will be done, but in your data center. That's what the cloud at customer is. On premise, now you've just purchased a Exadata machine. It's yours and you manage it from beginning to end. The advantage with the cloud at customer, you get all the services and the support, and we will do the upgrades and patching for you at the time you tell us. Likewise with Exadata Cloud Service, at the time you tell us and when you do it. Typically, the reason people go with a cloud at customer is because their data cannot leave their premises. Next slide. So this is the Exadata Cloud Platform. On your left-hand side, you see the software side of it. So multi-tenant in-memory database real application clusters. There's all the software. As much as anything else, this is for the PDF. I'm not going to go through every line in this, but you can also see the hardware on the right-hand side. So you've got the different structures that our friends at Sun have put in place for us for this Exadata machine. The key element that's really changed, and let me just take a minute on this, that's really changed in the last 5 years. It's really improved the speed. It's all around the connection between the servers and the flash memory on systems beneath. So in between there, you have the ROCE fabric, which is 100 gigabit fabric. We've had 100 gigabit for a decade in our Exadata machines, but the improvement from NVIDIA in the device driver is allowing us to read essentially, and this is loose talk, but this is to essentially take all the DDR4 memory in all the servers and all the flash memory that is in the database, excuse me, not database, but the storage systems below, and put it all effectively in memory as far as the system goes. And that's done through the flash cache, the smart flash cache, and the PM Connect, as well as through the low latency communication between the read and write to memory. Next slide. So this overview is again from 11 to 19C. Yeah, but the really don't want you to be in 11. You shouldn't be in 11. You're paying a lot of support costs if you're in 11 now. So the deployment is available anywhere. Again, lifecycle automation is in place, and you can subscribe and license it in a variety of different ways. What suits you and how you want to make it go. Next slide. So the management interfaces, as mentioned, sure, you can use a browser, and then you can also use REST APIs and all the different software development kits. Take a look at Terraform. Anything that you can do with respect to manage versions and move things around in configuration, that's a nice tool. In addition, you can do policies and compartment changes with that as well. Anything that you can do with the UI, you can do with Terraform. And then the other thing I just suggest you take a hard look at doing your things in scripts and software as opposed to going through it. Do it once the way you want it, and then the rest of the time do it in software. Next slide. So you can use the UI. Most people I know that have actually put together Exadata services, they do this all in CLI because they're used to CLI. They put things in before, but so you can do a local backup to your storage in the system itself. Next slide. Or you can go across to different regions with different different Exadata machines using disaster recovery with active data guard. So you're not going to lose your data. Next slide. Cloud at customer. Next slide. So typically, as I mentioned, it's about your data. It's the regulations, the latency, most latent. If you're doing Exadata systems, you're using fast connect. So latency usually is not an issue, but certainly it's a little different being on site versus, thousands of miles away. The speed of light is still a limitation. Integration tightly coupled with on-premise applications, and risk if your security guys are worried about multi-tenants sharing the cloud. Next slide. Next slide. There you go. So again, cloud at customer, all the same features. You can put autonomous database on cloud at customer too. All the features that you can do in OCI, you can put it in your Exadata machine and manage it completely as if you were managing it in your tenancy even though the data never leaves and the hardware never leaves your data system. That does not, by the way, that does not limit you to the rest of your tenancy. So the data that you're required to have on premise on your Exadata machine can be there. You can have a piece of you do have a piece of the cloud, your tenancy on site, but the rest of the cloud that you have, the rest of your tenancy can be in another data center, can be in any data center in the world in your tenancy, and you just move from region to region as appropriate for your data. Next slide.
So moving on, I'll take over from DataGuard.
Let me introduce Sunil. Sunil will be taking you through DataGuard.
Yep. With all of the services on OCI, as we saw a little while back in the manageability scale, there's a lot of different features that are available on all tiers of database. And we saw that DataGuard was one that was available on everything from the database cloud service, database on compute, all the way to autonomous. So what is DataGuard? DataGuard is a high availability disaster recovery tool that is going to be based on your in-memory redo logs, and it will allow you to take your database and have it essentially backed up against a secondary one. So the first configuration we have here is going to be for Oracle DataGuard, DG for short, and is going to be active passive. What that means is the active database is going to be a read-write, and the passive database is going to be read-only. So what's going to happen is there's 3 main modes you can choose: protection, availability, and performance. And they're going to give you different levels of prioritization for what will happen in a failover. And what would a failover look like? Let's say we have our primary data center right here, and for some odd reason, maybe there's just a crash hardware side, maybe there's a natural disaster, who knows? For some reason, it's gone out. What's going to happen is there's a listener that is going to see that the connections are not being taken by the primary database. And it is then going to fail over to the secondary site, which will now become the primary site. It will be a read-write database now, and it will take all of the connections. So if you wanted to have something be the most available, then what it would do is it would prioritize DataGuard, being it, would prioritize getting the secondary site up and running. And some of the in-flight connections will not all be added to the database when the database is made completely available. If your goal was to have the most protection, then what you would do is you would set it into protection mode, and it would prioritize making sure that every single transaction, every single in-flight connection is accounted for before switching to the secondary site. Now, this does take a little bit longer on the failover. So you have to understand what your use case is, understand what you're hoping to gain with DataGuard, and you'll have to choose accordingly. You see here as the last bullet points that this can also be used for simple migrations and upgrades. If you do have an active passive configuration and you don't particularly want to, let's say you have an upgrade that's going to give you a little bit of performance degradation, you don't want to experience that in your primary database, what you can do is you can simply make the shape of your passive database a compatible version upgrade, and then after you decide you need to switch, you can pull the plug on this database and it will fail over to the upgraded database. Now, this is something that you have to make sure you look through the docs, do your research, and make sure that it is going to work properly, because if you're on 12C or something and you're trying to upgrade to 19C, you're not going to be able to do that through this sort of method. Next, we have active DataGuard. And what active DataGuard is it takes the same concept that we had for DataGuard, except now you have two read-write databases. And some of the advantages of the active-active configuration is rolling database upgrades. This is the most obvious advantage, because if you have two systems that you can use, let's say one system is the primary system, other one's the secondary, we'll choose this one arbitrarily as the primary system. What you can do is you can upgrade the secondary system, and then after the secondary system is finished being upgraded, you can perform a switchover, which means these two databases are still going to be connected. And then now we'll have the secondary site, which has been upgraded, been patched. It's going to receive all the connections. And then what used to be the primary data center is now going to get patched. And you've patched two databases without having your end users experience any performance degradation, any downtime, anything of the sort. And also in the previous slide, when we did a failover, what's going to happen is if you're not on a managed service, which is going to be Exadata and the autonomous database, what generally happens is after you fail over, the secondary site becomes the primary site. And if you wanted to reset up DataGuard, you're going to need to manually configure, new DB system, shape, and then reset up the connection for DataGuard from the primary to the secondary. Whereas with an active-active configuration, they stay connected to each other over switchovers. And when we looked at autonomous a little bit earlier, we saw that there was a little menu, which you see right here, for enabling DataGuard on any of the managed services. That could be autonomous and Exadata. It's done programmatically for you within the UI. You could do this also through the CLI. You just have to write a script and put a variable in for each of these 4 fields. But the point is that you can take something that usually takes a little bit of time and understanding to do and automate it with something like the autonomous database. But on the flip side of that, if you have the expertise and you have the skill to do all of these tasks, like maybe you're trying to do something for auto scaling, any of these managed tasks that the autonomous database or Exadata are doing for you, outside of obviously hardware optimizations, you can do them on the regular database. It's just you'll need to go through the steps of doing it on your own. So lastly, we have Oracle Golden Gate, which is a data replication technology. Oracle Golden Gate is going to allow you to take data from one source and put it to another one. There's hundreds of connectors, which lead to thousands of combinations. And Golden Gate is, not just going to limit you to Golden Gate is not just going to limit you to Oracle databases. We see, there is obviously going to be support for Oracle databases. However, we see that, there's open source databases. We've got PostgreSQL, and then databases from tons of different other technology providers. We see, Azure SQL, Kafka, Hadoop, Cassandra, I think MongoDB is on here as well, MariaDB. So the idea is that you can take a very, very complicated data system that, previously might have required different people or different tables that you would have to manage all separately. But with Golden Gate, ideally, you can take data from tons of different diverse sources and very easily put them into one hub database, which will greatly decrease your manageability. And also, if you're trying to work on-prem and you want to have a copy of your data, you could have a central hub that also is going to take that data from the hub and push it back to your data center on-prem. So you have a copy of everything. So not only is this tool useful for integration, but it's also a high availability tool or disaster recovery tool that you can use it as. So we see, we have some examples of connectivity to Oracle versus non-Oracle. And for the replication patterns, how this works is you take your data set and you either have it as a broadcast or consolidation. So broadcast is your target pushes its data to many sources. Consolidation is many sources push data to one target. And you can have complex Golden Gate deployments where you'll have multiple steps in this process flow. And so you could have it so that you have a consolidation as one of your flows. And then after the database is consolidated, let's say there's a requirement for you to have data in not just one region, but in maybe multiple regions. So you could then push that consolidated data out to multiple regions. And per step in these flows, you can have up to 20 databases. And so you can create pathways for data to flow through very high dimension, very complex database architectures. And so we've talked about this a little bit, but generally we see 4 use cases for Golden Gate. The first one is going to be multiple cloud deployments. If you have data in one cloud and you need it synced to another cloud, Golden Gate's a great tool. It's got support for all of the cloud databases. So you're not going to have to jump through any hoops to get your data from one cloud to the other. It's very simple, very fast. On-premises to cloud, second most common. If you have database on the cloud that needs to be synced on-prem or vice versa, this is a real-time data replication tool. It's extremely quick. It'll allow for easy access to data on premises in the cloud and on the cloud in premises, so vice versa. Next two we have are SaaS to OCI. So if you have some applications, software as a service, that you need to push that data to OCI or to any database, that's possible using Golden Gate. And then you have multi-region. If you have data, whether it's in one cloud, whether it's in multiple clouds, that needs to go from one region to another. And so all of the data replication in Golden Gate is going to be done through trail files in comparison to the data guard feature or cloud guard feature, which was using the redo logs to do its data replication. So here we have another slide going through some more specific examples of common architectures that you would use a Golden Gate system for. And so we see some that are fairly obvious, like just database to database, to some that are going to be a little bit more complicated, where you have your source database, which is then going to be pushed to your OCI tenancy, which is then going to be used as a broadcast database to get your data to Azure, Kafka, Elastic, and AWS. Last thing we will take a look at in this presentation is the MySQL database option. The MySQL database is going to be the ability to provision a MySQL database system in Oracle Cloud. It's going to have 2 options. You can either create standard MySQL database instance, single instance, or you can create a 3-node cluster, which is going to have a, as the name would imply, 3-node system that's going to be spread across your availability domains depending on what region you're located in. And what that's going to allow you to do is going to have going to have high availability out of the box. This is very quick. It's going to have an RTO of minutes and an RPO of 0. It's going to carry all of your data, and it's going to have a generally high uptime. So we see here, when you're using a 3-node cluster, if you're in some of the regions in North America, let's say you're in Ashburn, let's say you're in Phoenix, let's say you're in a European region, you're in the Frankfurt, Germany region, then all of those are 380 regions. And what's going to happen is there's documentation that'll tell you how many availability domains are in any given region you're in. But what these availability domains are is they are physically distinct data centers. And I believe that's at least 50 kilometers between each of these. So, in an ideal world, let's say there was a small scale earthquake and one data center got knocked out, or there was, a big storm and some power lines got knocked out. Then because there's physical separation between these availability domains, unless a massive, massive scale disaster happened, then the other data centers should in theory be up and running. So we're going to have these 3 databases for MySQL that are all going to keep passing the data to each other, stay in sync through MySQL group replication. And if one of these databases fails, then the data is already going to have been pushed to the other 2 databases, and you'll be able to fail over to one of the secondary systems, which will ideally still be up and running and have the complete copy of the data from your primary. And this failover is very, very quick. It does not take more than a couple of minutes. Additionally, with MySQL, we have the ability to provision MySQL HeatWave. MySQL HeatWave is an extremely powerful tool that is essentially a massively scalable native query accelerator. Some of the advantages of MySQL HeatWave is it has support for both OLTP and OLAP applications completely in place. It is going to be using Eno database with the query accelerator on top of it. The data, as stated, there's no need for ETL. It can be run in place. You can query your applications in real time without any changes. And this is going to scale to thousands of cores. Now, on top of that, the HeatWave service is smart and managed. So things like high availability, things like database health are going to be checked in real time. The HeatWave node and the HeatWave node controller are going to be looked at automatically every 30 seconds to 1 minute. And if, within those time intervals, whether it's the 30-second interval or the 1-minute interval, the node controller detects anything is wrong, detects that it's not able to receive, any communications. After just, 30 to 60 seconds, the node controller is going to act. It's going to, kill whatever nodes are not effective and instantly replace them with new functional nodes. So it's extremely available and very performant. With that, that marks the end of the slides portion. I'll give everyone a couple seconds. If there's any questions that need to be asked, they can be put in the Q&A section. If not, I will have a demo quickly go over some of the autonomous database use cases and features. So give me a brief second while I reshare my screen. Okay, so here we are in the console. To avoid having to type in any of my credentials, I've already signed in and gotten to the areas we need to. If you wanted to get back here, you just type autonomous database and click featured. Right now, we can see that I'm in this database right here, the VC database. We see here we have a handful of different tools. Right now, something worth mentioning is that if you do want to experiment, you want to try development out on some of the managed services, specifically on the autonomous database, there is a always free version, which you get 1 CPU and 20 gigabytes if you do want to test out some of the features. Some of the features, because you only are able to have one node, are disabled. So we see that OCPU auto-scaling and storage auto-scaling are disabled just because you're capped at whatever the free OCPU amount in storage on provisioning that you were given it. But if you did want to enable auto-scaling, the way auto-scaling works is on a paid instance, it's enabled by default. What happens is, by default, you would click Manage Scaling, and you would choose to allow it to auto-scale. That would allow it to expand to up to 3 times specified OCPU count. And how the autonomous database would do that is it takes your CPU utilization numbers, and in continuum, it's going to continually crunch that data, and it's going to learn how your data behaves and when, from what points at CPU usage, you're likely to incur performance degradation. And it will smartly then scale up and scale down your environment to give you optimal performance and, pay-per-use that's truly in line with what you're using your autonomous database for. For storage, this is not going to be on by default, but you can choose to turn it on, and that will allow you to scale up your storage to up to 3 times the specified amount. As well as that, you do have a way to shrink your database, and this is a little bit more complicated in how it works. So you can click here and it will take you to the documentation, which will tell you everything you need to know about the shrink operation. For more actions, here, this is where you'd stop, start, restore, and create clones of your databases. This is also where you can work with the authentication and manage the encryption key. So if you don't want Oracle to manage your encryption key, you want to use your own key and put it in a vault and cycle it, rotate your key as you need to. This is where that would be. And if you are using a always free instance that you've done some work on that you want to keep, you can also just upgrade that instance to a paid instance. Let's see. So we see here, we have some metrics out of the box: CPU utilization, storage utilization, sessions, execute count, running statements, etc. This is a demo database, so we don't keep any data on here. We can also see that we have the performance hub. I don't know if anything is going to show up because there's no data on this database, but you would look for your metrics in the performance hub. And then lastly, we see database actions, which I've already logged into over here. The database actions are all included with the autonomous database. You see here that there's SQL, which this is SQL Developer that is already connected to your database. Right now, we're logged in as an admin, so we have access to everything. There is also regular users. And so on the topic of users, you have database users right here, which is a platform that will let you view all of your users, all of your roles, and then it will allow you to create new users, change roles, all through this UI. It's, you could do it as SQL, and it's just a lot cleaner, a lot easier to do it in the database actions page. For Apex workspaces, and for Apex is going to allow you to create a new workspace, and it's going to be connected to the autonomous database. So If you want to do connections through the autonomous database, you'll go into here and you'll be able to find your wallet file, or you can go onto the database node itself and grab the wallet file. Both are completely fine, both work. And what you would do from here is if you did just go into Apex, you'd be able to log into your workspace, connect it to the database, and then you'd have a little bit of a head start. You'd be able to hit the ground running on having all of your data pulled, ready to go towards your app that you were developing in Apex. For JSON, Graph Studio, etc., all of those are in here. You just click them, you can go. For administration, we also see that you have Data Pump, which this is a user interface that's going to help you view your different data pump jobs and use the wizard instead of API to help assist you in getting through a migration. In related services, we also see that we have the OML, or Oracle Machine Learning RESTful Services. And this is the API system for OML for Python. You also have OML for R and OML for SQL. What these tools are is these are essentially wrapping Python, R, or SQL around the Oracle database language. And what that's going to do is, underneath the hood, it's just a little bit faster than having to take your data and push it somewhere else. If you're using something like SQL Alchemy, you're going to be having to call to another language under the hood, whereas this is, in place. So it's a little bit faster, and it provides you with some increased functionality. For the database dashboard, you can put different stats in this. If you go in through the API, you can make this database a little bit more thorough. And then same thing with performance management. So I'll go back to here, and we see, I think this is a data warehouse, yeah. But if I was going to try and create another autonomous database, just for show and tell, when we create the autonomous database, we go here, choose the name. For the workload type, we choose the workload type right here. And to expand a little bit on the different workload types, these are essentially, given a signal to the autonomous database on how it should prioritize using its memory, what actions are the most important. And generally speaking, people will use a data warehouse or transactional processing database. If you are doing a lot of JSON-centric app development, you can use the JSON database, but it is worth mentioning that a lot of the optimizations that are built in to this database for JSON do make it so that it is less performance if you're not doing, JSON-centric or JSON document-centric workloads. So keep in mind, the JSON database is really, really tailor-made just for JSON workloads, whereas all the other three, they have optimizations, but there's not really any significant downsides to other workloads. If you want always free, flip the switch right there. I believe you can have either one or two always free autonomous database nodes per tenancy. And so, as stated earlier, by default, you'll have the OCP autoscaling, and you can choose to scale its storage. You'll create your credentials, put in the networking components, and then have a email address where you'll get the service announcements, and you would click create the autonomous database, and you're off to the races. Lynn was talking about Terraform earlier. We do see here that in the console, you have the ability to save something as a stack. A stack is a Terraform configuration file, which means if you did have a configuration that you made in the console that you wanted to keep as a script that you could use later, you see this in the create autonomous section, and you would see this in many, many other of the sections as well, the ability to save something as a stack so that you could use it later. So with that, we have a couple minutes left. I think that we might have a poll or two to close out the presentation, and I'd like to give the last couple minutes if there are any last minute questions. So with that, thank you everyone for being here and participating in the Database Day One Beyond session.
Thank you, Sunil. Thank you, Lynn. Just since we have about 5 minutes left, if there is something that you wanted Sunil or Lynn to show you in the console, now's your time. If you can put it in chat, then I'm sure Sunil and Lynn would love to show you. Or if you have any questions, please put them in the Q&A. If not, thank you so much. Yeah,
Yep.
go ahead.
I was just going to say, Sunil showed you the access points for autonomous, and in particular, I just call to the fact that if you enter the SQL, it gives you essentially, remember that the system knows who you are at this point, right? Thank you, Sunil. So if you enter there, you're essentially in SQL developer. It looks like SQL developer. You operate essentially the same way. If you go back to the menu again, Sunil.
Yeah,
Go back.
so the database tools menu. Sure.
Yes, thank you. So you've also got, if I could point out let's see, where's the ML?
It's
Machine
at the
learning.
bottom right. We took a look at it. So OML's down here. We
Well, that's
also
a RESTful. That's the one I'm looking for. Go there. Thank you. So if you go there, it might take a little bit to open up. All right, but it shows you a whole series of examples that you can look at, and remember that the machine learning in memory of the database itself is essentially Zeppelin workspaces notebook with SQL, but it also works as noted with RStudio, and it also works with Jupyter style notebooks as well. So if he goes into examples now at the under quick actions at the bottom, far right examples. There you go. So you can see all the different, so you can do all the different examples that they put in, different third-party packages, data selection, data store. So if you're familiar, or your data scientists are familiar with Pi, then do for Pi. And if they're familiar with R, then they can do for R.
Right.
And then likewise, if they're familiar with, just as Sunil pointed out, I'm just saying that you've got all these example templates in there as well that you can play with to move you to the next point.
Yep, and we got a couple questions in chat. So first one I see is, can you use the regular old standard SQL Plus client with the autonomous database? Absolutely. Can we use database metrics to create action like an OEM? Lynn, do you know what a OEM action is? Because I'm not super familiar with OEM, but I do know that the API system for both autonomous and Exadata has a bunch of different, and this is, like dozens and dozens of different.
Yes, the answer to that question is, remember, you have Oracle Enterprise Manager feature set. You get all the files, everything else. You can access them either as you have done it before with EM, or you can do it with ON observability and manageability through the system up front. The last question, can you use regular old standard SQL Plus client? Yes. So this is an Oracle database. The big difference is it's running on an Exadata machine. So you got a very performant hardware underneath, and it's also, we take care of all the scaling, all the tuning, and the issues with respect to patching and upgrade. So whatever is, and it will be done for you in the background, and it will not impact your performance or your actions at all.
One last question, Lynn, if you can quickly address that, and then we'll wrap it up.
Yeah. So what the last question is the Apex option during the Okay, so the
I've got to leave, but I'll let
that's
you
fine.
handle the Apex questions. Apologize. Really appreciate the work.
Yep, absolutely. So the Apex option in the database, what that's doing is it's setting up a basic environment in Apex. It's setting up the workspace. It's setting up essentially a landing zone where you would start to develop in Apex. You can do some of that stuff after you've created a database. So it's just skipping a couple of steps. If you know what you're going to be using the database for, you know you're going to be using Apex, then it just saves you a couple steps. And then for guides on setting up Apex, if you're trying to make a app, I'll put some documentation in. But generally speaking, there's tons of different resources in the OCI documentation on Apex, a lot of different guides. And the last thing I'll mention is there's a platform called Live Labs, which I'll quickly go to.
And then if you go to docs.oracle.com, probably you'll find a lot of documentation there as well.
So if you go on Live Labs, you'll see that there's plenty of tutorials for a bunch of different stuff. There's hundreds and hundreds of these things that can be done. So we see here, if you have a spreadsheet and you're just trying to get started, then there's a tutorial for this. And then you can see that they get more complicated. You can, instead of using a spreadsheet, you could use the REST data systems, etc.
Awesome. Thank you so much, Sunil and Len. I know he had to jump into another call, but really appreciate your time and help with this session. I hope it was a good learning experience for everyone. It's time for 2 quick polls, if we can get that quickly on the screen. For the first one, on a scale of 1 to 10, how likely are you to recommend this webinar to others, where 10 is most likely and 1 is not at all? Please remember that your feedback is very important for us, so please fill in the poll. It's a 2 question, there should be, okay, this is a 1 question poll, and as soon as you finish that, we'll have another poll on the screen where you can tell us about what topics you want us to cover in these sessions. So based on your feedback, we can add more sessions to these series or create new series, sub-series under Devon and Beyond. So we have just 19 people who have responded so far. If you can please. Okay, and we have the second poll also. Please go ahead and answer that poll. Our next session will be on July 18th, where we'll talk about deploying reference architectures in OCI. You can find the details on our Devon and Beyond page. And if you don't have that link, I'm going to quickly put it here. Let's go to everyone. Oh, no, that's not the right link. Just give me a second and I'll have the link up and running for you. And this link will give you information on all the upcoming Devon and Beyond webinars. If you have any questions that were not answered today or later on, if you have any questions, feel free to send an email to this alias that I just posted here. There's another scheme that's going on certification. If you're interested in getting certification, it's free. A lot of cloud certifications are free till end of August this year. So please go to this link and avail that wonderful offer that Oracle University is giving. We also do our hands-on workshop sessions every second Tuesday, same time, 10 a.m. PT. So the link that I'm going to put in here, you can use this link, and I'm going to add the next session soon in here. So please bookmark that. So that was a lot of links. I hope you all copied those links. And with that, I think we covered almost all the questions. If not, please send us that email to the alias because we are 3 minutes over the time already. With that, thanks again for joining us. See you all next time. Have a great day, everyone.